Well, warm welcome, everyone. Talking about IRF Research Forum for this institute. Warm welcome, everyone. So, welcome to the virtual conference organized by IRF Research Forum in association with Academic Fora and all. So, talking about the organization IASTEM, it conducts conferences in association with Research Fora, Research World, Academics World, World Research Society on the behalf of the entire organization. I would like to welcome you all. I'm Dr. Ravi Kumar. So, talking about the organization has about it's a decade-old organization and conducting conferences across the globe, physical and virtual, and giving a platform for exchanging between the researchers and connecting across the researchers across the globe. And when it comes to the publications, track record. More than 70,000, 75,000 papers have been published in this decade-old organization by various people who are associated, like more than 1.5 lakh people have been associated in the journey of our, decade-old organization. So, like organization conducts conferences or members meet in the field of science, technology, management, humanity, and all. So this is about a brief about the firm. And without wasting much time, let me just invite everyone for this conference. And we'll request, we have like more than 25 participants for the day, right? We can have the question as, we can have a time limit of maximum of 8 participants. We can 8 minutes per participant we can have, so that we can stick to the time and complete the session on time. And also with respect to the the question and answers and networking and all, we can also have like all the participants. We can take the queries and details offline in the chat box. So if the participants have any queries or any doubts, they can get back to participants in the chat box. And we all know we are here for research and collaborations and to understand and to network more in this process, right? We can have the participants to share their email address in the chat box, right? So that we can connect it if our interest matches and if our domain matches, or if you want to extend our research in your domain also. So you can share your email address and your affiliation and your expert area in the chat box, right? So that we can see uh, to collaborate and work and all, right? So without wasting much time, we'll quickly go ahead and start with the presentation sessions for the day. So I would, before that, let me take a quick group photo. I want all the participants to kindly turn on their video. So request everyone to kindly turn on their videos, because there are many people yet to turn on. Please turn on your video. Whoever have turned off, can you please turn on your video? Davala, because Neha, you please turn on your video.
Talk about the experiment we did in our college to have more students to our department. My name is Megumi Usui. I'm from Weber State University. We are located in Ogden, Utah in USA, and we have students, a little over 30,000 students. And I'm from the Department of Manufacturing System Engineering. And in our department, we have 3 major programs. One is manufacturing system engineering, another one is product design and development, and the third one is manufacturing engineering technology. In that manufacturing engineering technology, we have 3 emphases: welding, plastic composite, and production operation and control. I'm pretty sure everybody has the same problem with recruitment. It's really hard to get students nowadays. So we are doing pretty much everybody's doing, such as outreach, concurrent enrollment, articulation with other colleges, competitions, and other fun activities for younger students, and the summer camp. But It's still not clear results as long as I see it, and I think we are still misunderstood and we are still represented and all those things. So I did some research and found what we need to do. And here's the list of key approaches that I thought it's very important, which is high school outreach, industrial connections, and hands-on exposure. So I came up with an idea to have a senior project presentation with high school students and the local engineers as audience, all put together. So I want to explain what senior projects are in our department. Each student in our department must participate in the senior project to graduate, and that project goes 2 semesters long. First semester is designing, scheduling, cost estimation, pretty much planning. And the second semester is going to be actually purchase the material, and the students go into the machine shop and they fabricate everything as much as possible. Sometimes they have to do outsource because we don't have the capability, but still students have to plan it and get the cost and everything. So students will do all the designing using whatever the CAD programs they prefer to use. And the second semester, they actually go into the machine shop and lathe it, mill it, cut it, grind it, weld it, whatever they need to do. So I want to show you guys just one example of our senior project. So this tricycle, whatever you want to call, students designed it and they fabricated, and each student in this group took it home. It's theirs. So the experiment I did was to invite high school students and the local engineers such as Hill Air Force Base, Northrop, West Tech, and even students from other departments. And my goal was for them to interact between students and engineers and increase young students' interest in our field and increase the chance of employment and have a strong connection with the local industries. So actual event was held on the 18th of April at 11 a.m. We served lunch and everybody did an introduction, engineers and students. And after lunch, we had 3 project poster sessions. And senior students in that project teams, they have to answer any questions that anybody throw at them. And we had an interaction between students and engineers. And after the event, we sent out the survey to ask questions, and we got the positive and the negative feedback. Positive feedback was lunch was great, food was great, and they had a networking opportunity with industries. Students understood what's new in industries nowadays, and they got the business cards from local companies, and that it was a less formal interaction and the presentation, so people were very relaxed and that they liked it. Negative feedback was not knowing a dress code. It was my fault because I was not very clear on that. So some students showed up with a t-shirt and the shorts. That was not very professional. And introduction was too long because everybody had to do the introduction. And some engineers mentioned how we should prepare students more to sell themselves to industry who may hire them. And we should have provided an agenda. And maybe companies could have brought their information and brochures. So of course, we have a lot of improvement to do. Next time we can do advanced planning, get the better room and area, spread the word, expand outreach, increase outreach into high school, technical college students, invite more engineers. So we need to contact more local industries to participate. Maybe it doesn't have to be only local. We can go outside Utah and invite them. and have an agenda. A simple hard copy will be suffice, and keep the introduction to minimum. Only engineers can introduce themselves. And we had name tags, but it was not enough. So we should have more name tags. So for our next event that's going to be held in December, I already started collaborating with colleagues to secure suitable locations, and I am going to attend the senior project meetings to update students, give them way ahead notice so they can be prepared. And I already reached out to technical colleges, so I need to do that for high schools, and notify members of the industrial advisory board members so they will attend. More engineers will attend, and I will create posters, and then we're gonna display it all over the place. So, any questions?
We have done a project on harnessing machine learning for cloud security threat identification. So we have done many things in this. We have done some research work, and we are going to explore how machine learning can enhance cloud security, and it migrates a potential threat. We'll understand the benefits of this approach in safeguarding a cloud-based infrastructure. Now we'll go into enhancing the threat detection, learn how machine learning and algorithms can analyze vast amounts of cloud data to detect anomalies and discover advantages of proactive approach. Uh, and we have also seen into automated vulnerability scanning, understand how machine learning can automate the process of identifying vulnerabilities in our cloud environment, and gain insights into our technology can help us to stay ahead of evolving threats. And we can have many threats where we need to practically or in person we need to involve in it to check that we need to detect them in person. So instead of that, we'll be doing with machine learning by predictive risk modeling, explore how machine learning models can analyze historical data and patterns to predict potential security risks in our infrastructure. And we'll be investing more capital in those. So we'll be using machine learning with heavy protection measures, and we learn how to leverage the information, implement reactive measures, and strengthen our overall cloud security posture. Adaptive security orchestration, discover how machine learning can enable adaptive security orchestration, where our infrastructure should not get damaged. And by through machine learning, we can gain many advantages. Um, In-person members need not to be there, and it will be done through servers and protocols based on evolving threat landscapes. A conclusion for this: securing the cloud with ML. In conclusion, integration of machine learning in cloud security has the potential to revolutionize how organizations proactively identify and migrate the threats. By leveraging this powerful technology, you can enhance your cloud security posture and stay ahead of evolving cyber threats. Thank you, everyone.
Thank you.
Okay, so let me start with introduction. Good afternoon, everyone. My name is Sankal Jain, and I graduated from SRM University and currently working as a data scientist at Genpact. So I'll be explaining you about the emotional and personality recognition. So what is it about? Okay, so the introduction. So basically, it's related to the realm of affective computing, which is a study and a development of systems and devices. And it's basically mostly concentrated on the recognizing, interpret, and process, simulate the human emotions. And the paper is mostly concentrated towards the emotion and personality recognition, using the text inputs to know to recognize the personality traits of an individual, and by analyzing facial expression, it will analyze the using video, it will analyze the facial expressions, and as well as for sound, with the tone of frequency, it will analyze the emotion of it. Now the problem statement. So basically we are aiming to create an emotion and personality recognition which aims to include text inputs, audio and video to determine the several aspects that define a particular emotion of an individual, which I've explained earlier. So our main objective is so basically we have created one interface, a website interface where all three separate modules will be present: video, audio, and text. Now, an individual, it could be a student who is practicing for interviews, or a corporate people who wants to give a presentation in a more efficient way. So they would be interacting with website, interacting with the video part and video part, where they'll given a question and they have to answer within 45 seconds. And it will analyze that facial expressions in video part. In audio, the tone they are speaking, the frequency of that tone, that will analyze. It will get analyzed and will give us the emotion output. And for the text, we'll be giving a question and they have to write their perspective there. And analyzing their response, you'll get a personality trait of that particular person, which will help them to enhance their efficiency in presentation, as well as having a positive mentality and a positive expressions and a positive tone as well. Furthermore, we can store these readings, an individual reading, whoever interacting with our website, in a data set, and which will be act as a training data set for a future scope of multimodal emotion recognition. Right now, we have all three different separate data sets for it. Now, innovations of our project. So as I've explained, it would be a user interface and they would be interacting with it. Well, the future scope we are concentrating on it would be the user reading, which they whenever they will interact with the website, it will store in separate data set, and that data set would be user training data set for multimodal emotion and personality recognition. So the literature survey, whatever we did, what are the findings and challenges we found in existing system? Well, we can say that every researcher is taking just two aspects of it, like say a text, audio, video, rather than taking all three of it. So I have combined all three of it and to try to make it a single one, which would be a multimodal in a future way, in a future. And the scope and future scope, and coming to future scope and application. Well, this could be, there is no currently any data set present which has a single data set in which facial expression, audio, and textual input, all three are there. It's all a different data sets are there for text, video, and audio, which won't be make it as much efficient as it should be. Well, we can use these models for the students to prep for the interviews, as well as for the corporate offices to give the presentation, to have a smile on their face, have an happy expression, a positive tone set, and as well as the way the content they are presenting, it should be somewhere of a neurotism, which should be in a neutral way, or it should be more towards a positive way, which will make it all efficient. Now, let me tell you the flow of it just by showing you the UML diagram. So a user would be, as I've explained earlier, that user would be interacting with the website. Then they have to, like you can see the request tab where they have to give the permissions for allowing for video and audio. Then there would be a question. Then video would be recorded while they will answering the question, and it will analyze the facial expressions. Same as for the audio, they'll get a 15 seconds. Right now, it's a limitation of 15 seconds. They'll have a 15 seconds to record their audio and answer that question, which will help them to analyze the tone of it, the frequency of a tone. And for the text, they have to write their perspective, which will tell the personality of it. Now it has been divided into three different modules, which would be examining, recognizing, and representation and usage. Examining, they are basically interacting with the website and answering the question. In recognizing, they are analyzing the response for those questions. And represent and usage, basically a website will give them the output with compare with other candidates as well. Coming to the technical aspect for it, now what we have used in text models, so all the pre-processing techniques has been done using NLP, and then word to vec input has been used. That embedding has been feed into multiple CNN layers to get the phrases, to get the more contextual phrases, and to get the more sequential context of it. We have feed it into LSTM, and then we'll get the final output. Now for the audio model, we have used two different models, CNN, LSTM, and SVM. Both have performed very well. Now talking about the SVM here. So how that audio segment is analyzed, then it will convert that continuous signal to discrete signal. then pre-emphasis would be done, then followed by the framing, then hemming would be done to cut down the discontinuities, and the feature extraction. And the feature extraction would we would be doing using MFCCs, and then we'll get the final output for it. The tone frequency, what emotion it's basically a user is using. And coming to the last final architecture diagram would be the video. So here we have applied the data augmentation to enhance the training data set. Then point-wise convolution is applied on. So basically point-wise convolution would be that each pixel would be analyzed by 1x1 filter to get the better extraction of it. And then depth-wise convolution would be there, that each filter would be applied to each input segment, input channel, which would give you the more efficient output for the facial expressions. Now here is the implementation. We see that here we can have 5 types of psychological traits are there using the text analysis, which would be extroversion, neuroticism, agreeableness, conciseness, and openness. So whatever the response they have written, the most visible trait would be there. And the perceived emotions using audio analysis, whatever the tone which has been recorded, what does it I would say on which frequency it is on. Is it a neutral or a sad or an angry? And then for the video analysis, the face expression, they will analyze the face expression and it will tell which expression it's most focused on. So our aim is to enhance the presentation skills as well as the practice in interviews, to have a smile on their face, have a calm and neutral tone, and have a positive mentality. That's all for this. Any questions? Thank you so much.